Scheduling queues, a process enters the system, they are put into the job queue, the process that is residing in the main memory and are ready and waiting to execute are kept in the ready queue. P1 is a new process created, P2 is a new process created, P3 is a new process created. All these new processes will be put inside the ready queue. The list of processes waiting for a particular input-output device is put in the device queue. Each device has its own device queue. Scheduling queue. A new process is initially put inside a ready queue. So there is a new process. This new process will be initially put inside a ready queue. P1, P2 and P3 are new processes and they will be put inside the ready queue. It waits there until it is selected for execution and dispatched. Once the process is allocated, so suppose P1 is removed, P1 is allocated inside the CPU for execution, one of the several events could occur. So now P1 I am removing it and I am dispatching it for execution. What can occur? The process could issue an input-output request and be placed in the input-output queue. So suppose this P1 is a C program for addition of numbers. What will happen? It will send a input-output request because it will need an input of number so that it can carry out the operation. The process can create a new sub-process and wait for the sub-processor. So inside this process, one more process can also be created. There could be termination of the process. The process could be removed forcefully from the CPU as a result of an interrupt and be put back in the ready queue. So because of some kind of interrupt, because of some kind of interruption, that process can be forcibly removed from the CPU and it will be put inside the ready queue. So suppose there is another process, say P2, and P2's execution is more important. What will happen? P1 will be forcibly removed from the CPU and will be put in the ready queue, and P2 will be dispatched for execution because P2 is important and not P1. Execution of P2 is more important. So it will be P1 will be forcibly removed out from the CPU and it will be put inside the ready queue. Queuing diagram representation of a process. There is a ready queue. Ready queue, the processes will be allocated and to the CPU. So it will be dispatched for execution from the ready queue. If there is an input-output request, what will happen? It will enter the input-output queue and an input or output operation will be performed, and what will happen? It will be going into the ready queue. If there is a time slice expired, so there is a time out, then the process will be forcibly removed out from the CPU and it will go inside the ready queue. Fork a child executes, process goes to the ready queue. Waiting for an interrupt, what happens? An interrupt occurs. Some other process is more important than the process which is executing. There will be an interruption and that initial process will be going inside the ready queue. So if there is an input-output request, there is a time slice expired, fork of a child and waiting for an interrupt. In all these cases, the process will enter the ready queue and from the ready queue it will again go to the CPU for execution when the conditions are fulfilled or satisfied.